Welcome back, everyone. Previously, we discussed the plots of linear functions, which give straight lines, as well as their slopes. In this video, we will be discussing parallel and perpendicular lines. You have likely come across these terms, but we will give their definitions and how to use slope to determine if the lines are parallel or perpendicular from their equations. First of all, parallel lines are lines that never intersect, meet, or touch. These parallel lines go in the same direction off to infinity. All of these would be pairs of parallel lines which will keep going on forever and never touch. In fact, they will always remain the same distance away from each other, no matter how far we draw the lines. A symbol we use to represent parallel lines are these two horizontal bars. Next up, perpendicular lines are lines that intersect or meet at 90-degree angles. These 90-degree angles, or right angles, can be seen from these perpendicular lines. Here's one pair, and another, and one more. At each intersection here, the lines form what looks like the corner of a box or square. Looking for an intersection where you are able to make this perfect box or square is what tells us if we have a 90-degree or right angle at our intersection. And when we do, that's when we have perpendicular lines. The symbol that gets used to represent perpendicular lines is this symbol right here. Now that we have discussed the definitions of parallel and perpendicular lines, let's look at how we can tell if two lines are parallel or perpendicular by looking at their functions. Recall the form that we often see equations of lines in is the slope-intercept form, y equals mx plus b, where the m is the slope. The way we can determine if two equations will give parallel lines is simply if they have the same slope. For an example, consider these two equations. Both are already in slope-intercept form, so we can easily read off the slope as the numbers multiplying the x's. In both of the equations, the slope is 2. Let's go ahead and plot these to see if they end up being parallel. Going off what we learned about plotting using the y-intercept and slope, this first equation will have a y-intercept at -1, and the slope of 2 tells us that if we go over by 1, we should go up by 2. So our next point should be here. If I go ahead and connect these dots, there's our first line. For the second equation, we have a y-intercept of +2. And again, the slope is 2, so if I go over by 1, I'll be rising by 2. Then I draw a straight line through my points. Then sure enough, it looks like if I keep drawing these lines forever, they'll always remain the same distance and never touch each other. So we see we get parallel lines when they have the same slope. So, two equations with the same slope seem to be parallel. However, there is one exception, and this is when the two equations will give the exact same line. When this happens, the lines overlap and are always touching, and so by definition are not parallel. Consider these two equations. In order to properly read off the slopes and see if they will give the same line, we will want to get both of them into slope-intercept form. The first equation is already in the appropriate form, but with the second one, we'll need to distribute this 2 into the parentheses. When we do that, we see we end up getting the same equation, 2x plus 2. So even though we now see that they both have a slope of 2, when we plot them, they will both end up giving a y-intercept of 2, and from the slope our next point will be 2 up and 1 over, and both equations end up giving us this line here. and because they are the same line, they are always touching, and so are not parallel. Finally, for perpendicular lines, it's a bit trickier. For two lines to be perpendicular, their slopes must be opposite in sign and the reciprocal of each other. Let's start with this equation as one of our lines and determine what the slope of another line must be for it to be perpendicular. Again, we have a slope of 2 here. Now for the reciprocal, recall that means we take a fraction and flip it. So first, let's get the slope into a fraction. 2 can be written as 2 over 1. So that means the reciprocal is just going to be the flip of this, which is 1 over 2, or 1/2. But we also need to have the opposite sign. We will have a negative out in front. So from our rule, a perpendicular line has a slope equal to negative 1/2. There are no restrictions other than having this slope, so just for an example of a perpendicular line, let's have y equals, our slope has to be negative 1/2 times x, and let's do plus 4 for our y-intercept. Let's plot these two lines to see if they are in fact perpendicular. For this first line, we have a y-intercept of negative 1 and a slope of 2, so again we go up 2 over 1, connect the dots, and there's our line. Now for our second equation here, we have a y-intercept of plus 4, and our slope of negative 1/2 means if we rise by negative 1, we should run by 2. So our next point should be here. Connect the dots, and then sure enough, we have a right or 90-degree angle at our intersection. And so we have perpendicular lines. With that, we have gone over parallel and perpendicular lines and how to determine if two equations will give such lines by looking at their slopes. Until next time.